Hello and welcome to another video. This is Great Swamp and this is Mr. McCormick, and this is Great Swamp National Wildlife Refuge. Now my niece thinks that I look like a ninja and is going to scare the children dressed like this, but this is hashtag responsible social distancing, I guess hashtag COVID-19 ninja if you want that. But I am being responsible, so we are at Great Swamp, and if you look behind me, you can see there is a wetland. I'm going to talk more about that in a second. This is a large National Wildlife Refuge that includes a large freshwater wetland. So as we're here at this large freshwater wetland of Great Swamp National Wildlife Refuge in New Jersey, yet again, just want to point out a couple of things. You could hear and see the Canada geese that are just hanging out, swimming in the end of that puddle. You've seen Canada geese before. That's my best zoom for you. But if you take a look, you can see different layers of vegetation, and that's what I really want to talk about here. And you can think about the resource used by different animals. So having the ability to have these different layers of vegetation and use these resources differently lets more species and more biodiversity exist in a given area. There's the idea of what we call a niche. You can pronounce it niche like you used to back in my old days, but I think niche is more proper and people are doing that now. But anyway, the idea of a niche is that each species has resources that they use and things that they do. It's really everything that a species does in their lifetime. And you can think about resource use as part of that because that's what they use when they're alive. That just makes sense. And if you have two species that share too similar of a niche, they can never have the exact same niche. The competitive exclusion principle says that over a long period of time, one would outcompete the other, so that's impossible long term. But if they're too similar, if they overlap too much, also competition is a real problem. So one thing that organisms do, including birds, for example, you may see those geese in the middle of the pond using that area for their food. They use other things too. You've seen them on grass and all that. But anyway, they could do that. You have shorebirds, including Wilson snipe that lives here, that would be probing into the mud. And therefore they can live in the same spot. They're not using the exact same resources and they're not competing as strongly with each other. So that's the idea of resource partitioning. It's kind of sharing, they're not intentionally sharing. Evolutionarily, they've evolved and adapted to their environment in a way that lets them and permits them to both be in the same spot. When we talk about aquatic ecology in places like this, think of layers under the water as well. I mean, here you could just see detritus and old leaf litter that's built up. But most of this is what we call emergent vegetation, which comes out of the water. You know, if you take a look out there, comes out of the water and then is above the water for some portion of that plant. And obviously that's a good way to get sunlight, photosynthesis. Yes, all of them need photosynthesis. The light does penetrate into the water, however. You do see, if you take a good careful look here, some of this, although it's not in really good shape right now and should get better as the springtime goes along, if you see some of the larger leaves there, they're going to be floating vegetation, or it appears to be. And below that, if you take a good careful look, there is submergent vegetation. It's submerged. That's where it lives. It lives underneath the water. And it's still, because the light can get in that deep, it is still photosynthetic, of course, but you do reach a spot if the water is deep enough or turbid enough, meaning there's a lot of sediment in there, and it's just the light can't really get through that sediment. It's murky, it's muddy kind of water. Then there is a zone that will be reached where photosynthesis is no longer possible. Little stand of trees within this forest what you realize is they're all really small. They're really skinny. They're small in diameter. And what this tells you, and as well as there's really not that much except for some of this multiflora rose on different levels. This tells you that this is a fairly new secondary growth forest, that this was cut down at one time, and probably being allowed to regrow now because of management. So, think about human influences. It does get rid of a lot of the structure, vegetative structure of communities when we cut down trees, for example. And that is one effect it would have, obviously, is, again, if everything is pretty much the same, there are less species and less biodiversity that can exist. And therefore, the community itself is less resilient and able to bounce back from any kind of disturbance that occurs. They can resist it if there's more biodiversity, and they can be more resilient and bounce back. Resist means it doesn't really change. Without biodiversity, either one is very difficult, especially resilience. And again, that is the bounce back ability. Okay, so this tree, and one reason you can tell at this time of year pretty easily, is an American beech tree. It's a small one. It's a very small one. It's a young one. And American beech keep their leaves over the winter. You can see how they have serrated. You really can't see the serrated edges so much on the dried out old leaves. The new leaves would be, and you could actually see that pattern on them as well. Now, American beech, this one even as a youngster, does have nice smooth gray bark, or it's supposed to, and just pretty much like that. But that is a bad example in many ways. But anyway, so they have nice smooth gray bark, except when they are having problems with a parasite. So we're going to tell you the story of the American beech right here, and we're going to also go into the ideas of mutualism and parasitism, and explain how complicated interspecies relationships can truly be. So the American beech tree it was brought over. It's not from here. The American beech tree is from here. That was horrible. But the European beech tree exists in Europe. And there is a parasite that was brought over unintentionally on European beech trees from Europe. And it doesn't exist here naturally, and therefore these American beech trees are not genetically or in any other way adapted to it. And it's called a beech scale insect. If you take, it's Cryptococcus phagosuga, and it's this little crawling critter that has a stylus by which it feeds, and it secretes a waxy substance over it. And anyway, so what it does is it weakens the tree. The tree does have defenses, just like we have an immune system and defenses too. But this really weakens it. And then there's some fungi that take over. And when the trees get large enough and have enough parasites on it, enough of these beech scale insects on it, the fungus infects it after it's been infested, and the trees can snap in half. Now, obviously, a parasite, in this case, both the fungus and the scale insect count as parasites. And parasite is just an organism. Parasitism itself is when one organism harms another organism while it itself benefits. And we're talking about in a co-evolutionary time frame where they're adapting to each other, not just one time that you hurt me. No, that's not the point. So it's always that, where there's a net negative effect on one species and a net positive on the other. This also brings into the idea of blue jays. Blue jays eat beech seeds. And because they do eat beech seeds, that's bad for the tree, right? They don't like that. That's their babies. And beech seeds also can help them get away from these scale insects, which don't fly or anything. They just blow in the wind. They really get close, only on trees that are close by. So if you're large enough and close by, you're probably going to get it. But if you're not, if you're a social distancing tree, then that's not how it works, but whatever. But if you are doing that, if you're farther away, maybe a seed dispersed far away, and we could talk about seed dispersal another time, then that would be an advantage. So maybe the blue jays help them out, because what they actually do is they take those seeds and then they carry them as much as a kilometer away and bury them in the ground to come back for later. But sometimes they don't. Sometimes the blue jays die. Sometimes they forget. They only forget like 40% of the seeds that they bury, but that's still substantial. And then that tree can grow into another tree away from the parasite. This actually goes into the escape hypothesis and the idea that you can get away from the conditions around the parent, and that's an advantage. So what is the blue jay in this story? Is it a parasite of the American beech, or is it in a mutualistic relationship? Well, if the benefit is greater than the harm caused by eating all the babies, then that would be mutualism, because that relationship has been around since the last ice age. But it might only be a slight mutualism. These things exist on a scale. The third one that exists on that scale, which may be more theoretical than anything else, is the idea of commensalism, where commensalism means one organism gets nothing, neither harm nor help, and the other one gets a benefit. Like barnacles on a whale. If the barnacles have no effect on the whale, they get a place to live, they're good. So this is just a little lesson on species interactions and how complicated they can be. And they can even change depending on the changes in the environment. Yeah, great swamp. Here is a swamp. I mean, really a lot of what you've been looking at with the water bodies today even were the freshwater marsh, but this is a swamp. You see trees instead of reeds and grasses. Yeah, there's some grass there, but that's not mostly trees. Look. Now this is a really good example of an old beech tree that's doing quite well. It appears to be. And for whatever reason, most of the time the old ones do lose their leaves during the winter, but this one has kept some. Not all. Most of them are gone. And we can talk about the plant hormone that's responsible for that, but we're not going to do that right now. So I just wanted to show you how smooth the bark really is. It's a really pretty tree when it gets to be old and it is in good shape, and it doesn't appear to have any of the scale insect on it, which is a good thing. So I just wanted to show you that once I came across one that was nice and didn't have so many lichens on it like some of the ones in this forest do, which is not bad for the tree, but it doesn't give a good example of what they typically look like. This is what they look like. I'm going to go and see if I can get an owl on this tape. There is an owl. It is there somewhere. I know I'm pointing it in the right direction. It's a barred owl. I actually called it over after I saw it, so I'm going to try to do that again. And they respond pretty well, so let's give it a shot. I'm going to sound like an idiot, and you're going to like that. So I'm going to keep walking kind of towards, but they're shy. So as I do that, that's not going to work. You can see him. He looks like a little dot in the middle of the screen right there. Let's see if he moves. He's flying right now because of that. I don't know if you saw him fly. He flew away. Not really what I wanted. But, hey, he was on tape. But that's a barred owl. They're quite common over here. And they are nocturnal, but they're still around in the daytime. It's not uncommon to see them like wide out in the open here, but it's because I'm so far out, really. Kind of out into these woods here. And I'll zoom out a little bit. And I'm going to try to find my way back out because I'm kind of off the trail too. I'm not trying to be, just, yeah, well, wish me luck. Maybe I'll put this video online. Maybe I'll never get there. Bye. So I'm going to talk and walk. I'm leaving the owl alone. Actually, he didn't go very far. I feel like Deadpool. Actually, he didn't. No bad jokes. I'm not going to do it. But he didn't go very far. He went to a tree pretty close by. But it was in a place where it was even worse. And he's looking right at me. And tried to get them in the binoculars through the camera through the binoculars. That didn't really work out. Again, it's a barred owl, B-A-R-R-E-D, not barn owl. There's two different kinds. Barn owls are white. This one is gray, and look them up. They're common in New York and in different areas as well. But just wanted to give you an idea of, you know, what happened after I left. I can get them to call back often at night, and they won't call at this time of day anyway. So I was curious what would happen, and he just flew to a tree maybe 10 feet away and then looked at me. No, I left him alone. It's always better to leave the birds and animals and all those things alone, just so you can see. That's what I'm walking down. It's not muddy in this spot, but if you thank you. And this is what I've really been doing for this video. All for you guys. Look at all the wonderful stuff that I'm walking through. And there's really not much of a way around most of it. Huge puddles. Yeah, I'm dedicated. This, you know, I love you guys. There you go. If you take a look, this is a log. Yes, okay. And actually it's cut because of the trail, I'm sure. But it does, dead logs on the forest floor provide a vital resource. They are hiding places. They're refugia. They're detritus-based communities that live underneath it because they're eating dead stuff. And there's a whole little ecosystem that occurs just underneath these logs. And sometimes you find some things that are really good. I'm just going to use my one hand here as I record, because that's all I need. You know that. I got this. And let's see what we find underneath. Underneath here, we have almost nothing at the moment, it appears. The funny part is, I tried to cheat and lifted up this log a few seconds ago before I did that little introduction and did the nature show type thing. And the little guy escaped me by magic. Let's see if we can find him, and he'll just magically appear somewhere on this video. In case you didn't figure out the movie magic right there, I am actually not in Great Swamp today. This is the day after. Couldn't find a salamander. That was just cheating. I am in Heavenly Farms, and it is a small park that is in New Jersey as well, in Middlesex County, and it's much different than Great Swamp, but I just wanted to show you that, and also give you a proper goodbye. So goodbye to you all.